Welcome back to the Geometric View, Season 8, Episode 90. Today we get into the harmonic relationships between electromagnetism, harmonies in general, and how frequencies produce dissonance, harmonies, constructive and destructive wave resonance. Stay tuned, it's all here. The Geometric View is a Love is Watching production. We have no sponsors, and we are not on Patreon. The link is in the show notes below. Let's get into the circuit. We greatly appreciate your support. The best way to donate to us is on PayPal. Just send money directly to goldenscaling@gmail.com. Thank you very much.
Times before you get a repeat in the harmonics of that area that you're looking at. And so for example, you get a moon harmonic and planetary moon distance harmonic, planetary distance harmonic from suns, star distance harmonic from, and so all these levels. These are all expressed in harmonic series, and I'm finding that just about every phenomenon is conforming to these, and so of course do numbers. So that's a big thing I've been looking at. I've been looking at what's happening in Blender and the game world these days at the moment. Not by playing any games, but by so seeing what the computer engineering inside of them is. That's what I'm kind of interested in, especially the AI behavior trees or goal action planning or neural networks or utility based decision making. So all these things, and so I'm looking at quite a lot of Unreal Engine and Blender and stuff like that, and lots of different stuff really. JavaScript nodes and bloody loads of shit. So that's me at the moment.
Yeah, I find it interesting that we're on that. Speaking of harmonics, that computer engineering wave. One of the big challenges for the work that I'm doing is pre-engineering the processor to be 1024-bit. Of course, that's just a base starting point. I really want it to end up at 2056-bit and beyond for the future, and trying to design all this in a manner that thinks about the future and get away from the Intel. About the only thing that I think is worth keeping out of the Intel architecture is the concept of the universal serial bus, and it just would be a scaled up architecture. But this entire x86 design work, I want it to go away, and the science is finally reaching that point now. Unfortunately, obviously, a lot of things are under certain patent controls, and got to figure out ways to do that, to get around that. Got to order now.
What's funny in the game?
No, you're still here.
No, you haven't lost audio. I can hear you.
Oh.
What was?
Oh,
did you ask me a question, or did you ask somebody else?
No, I was asking Nick. That harmonics. Well, you'd answer it. That would revert to frequencies, wouldn't it, Ramon?
Well, by definition, yeah.
Yeah.
Harmonics is referring specifically to frequencies, and it's something that's it's implicit in EPMC. I probably could spend more time, talking about it in the paperwork, but it's just how things work, So it's there's so many people doing good work in that area that I don't spend really any time in it, but it's a incredibly important aspect. It's all under the law of resonance. So, I don't spend a ton of time on it psychologically. The Chinese and other, Asian philosophies, spent a ton of time on it themselves. And then there are men who are far more interested in acoustics and cymatics, and they put a lot of good effort into it. And I definitely recommend that people look into those. I myself don't spend a lot of time on it because I'm coming from a different angle. But it's totally part of the extensions discussion, because all the laws, the 8 laws, are all part of the P power. So the law of resonance is no less important than the law of causality, and no less important than relativity, and then vibration, and then conservation and polarity, because they're all actually one law that's being seen in 8 different forms. And the law of resonance is situated almost in the most, you could say, the most influential position, because it's nestled between the law of polarity and the law of causality. So whether you're doing the forward rotation of the cycle, where the yin, the yang polarities are informing the causality, or you're going the other direction, where the law of causality is influencing what harmonizes and doesn't harmonize. Either way, it's situated, in that key position. The Chinese called it joy, or lake, or the youngest daughter, in the Noah family schematic. And it really refers to how to actually control reality and be happy. And that law of resonance is in a kind of a relationship. After the law of causality comes the law of evolution, or flux, or change. And so we know that the resonance and the changes are incredibly related. And then if we go down below, on the other side of polarity, it has another kind of harmonic relationship with the law of rotation. So things going in cycles, and then of course cycles and changes are exactly opposite of each other. So resonance would be kind of a controller. Obviously, the law of causality and polarity, and then nowadays vibration is in quantum mechanics and relativity. Those 4 positions are considered the masters because of the north, south, east, west. But if you think about it, you can't really get from north to east without going through northeast, and all the way around, same thing. So you can't, without the changes, conservation, rotation, and resonance, you really can't make those primal cardinal direction laws work at all. So, and resonance of any of the 8, if one was to spend an entire lifetime focusing only on one, you have an entire civilization focused on causality. And where has it gotten them? They still have, a fecal oral water contamination. The one to spend on, and one of the biggest keys for Western science is that it accidentally harped in on, is you resonate with the result that you're looking for. If you resonate with the result you're looking for, your causality gets better. In our case, the scientific method tuned us into a specific thing, which was looking for scientific outcomes and eliminating the unscientific things. And that was a very useful resonance. It had a different kind of dissonance as well, but it
into mute.
Yeah. Ramon, you muted yourself.
Yeah, he's probably got to deal with something.
Yeah, that was quite. He was doing a good job there.
Yeah, sorry, Andy. Earlier I couldn't find me. I'd muted myself. The bloody phone. I couldn't find to unmute it again. So
that's all right.
Yeah.
Yeah. Well, the question. Keep going, Nick.
Sorry, Andy. Yeah.
No, keep going.
Yeah. This guy Toms is a New Zealand bloke. He was on that Demystify project, and he started looking at cycles because of the stock market, and had quite a lot of success on it. So they founded this foundation for the study of cycles, and it adheres to a lot of the people we've been talking about. But he's found all sorts of things with redshift and how it isn't valid. I think he adheres to most of the electric universe principles. But he's done these things, like found the fundamental harmonic by studying all these cycles, you can get back to the primal wave, really. And it's at the moment it's decided that the universe is about 10 million times bigger than the Hubble can see at present, at least, you know. It comes out with very interesting comparisons, and there are all these. In his stuff, he takes time and distance, sort of time space, to be the same figure, really. And so then he does all these comparisons by multiplying the frequency of these particular cycles, some of them by light speed, for example. You come out, you can do the same thing with sound, apparently. They conform to these same ranges. But anyway, basically, by using this Fourier analysis, you can find these cycles in just about any data that you look at, any sort of time series data that you've got. You can start finding these, and a lot of them seem to correlate with the movement of the planets. Particularly, there's the conjunction of Venus and Jupiter, and there's also the thing about when Saturn goes through the ecliptic. There are the massive jolts on the. It seems to be massive jolts on the system that this Schnall and Sciaffetti were looking at, and it seems like this. It's a wavelength. He believes in the ether, and it's some kind of shock that goes through the ether and affects actually the strong nuclear force. He reckons, and I think they're identifying these at the moment as gravitational waves. It seems to be. It seems to be at these points. They seem to be at the classical astronomical points that they occur in the planetary and solar conjunctions and the moon and all that business. So they all have a massive effect, just for a start. And whether there are other cycles that have been found which go over millions and thousands of years, and they're expecting, you know, a lot of these vary a little bit in the amplitude, so that's where they land, by a few percentage points here and that side, but they generally come in one form or another. So that's interesting. That's all interesting stuff, and there's a lot of good people looking in those kind of areas, which I find interesting. Quantum computing, yeah, I can see. Well, it's just so yeah.
I think that.
Yeah, go on, buddy.
I think that sound organizes matter. We can see this through cymatics. We can see the patterns that are created through different frequencies, but that same thing happens inside of Markland convection.
Yes.
There's articles, recent articles that have been written that says that there is sound that comes directly out of the sun. I just did a Thunderbolt's presentation on the sound of light and how light makes different sounds. And my next one I'm probably going to do is the shape of sound, the shapes of sounds. And if you look at Markland convection, I think that and how it organizes the individual elements that are coming out of the sun, it organizes them using sound. And I'd like to say that those sounds or the organizational structure of it, where the matter sits on the tubes within the tubes within the tubes of the Birkeland currents through Markland convection, is the harmonic series. It sits on the harmonics, whether it's the wave peaks or the wave troughs. It organizes in harmonics.
Yes, yes. And may I say that this is what Torms is saying. But the other point that he makes is that because forward you get a scale that goes up in musical fifths every time you're doubling, and you get an octave of that particular note, and so the ones in there. And he was saying that basically the chemical constituents of the planets in the correspond to their harmonic their place on the harmonic series in that particular system. So he's saying that, but that's at two levels. He's saying there's a beyond Jupiter level where you have the gas planets, and their constituent molecules apply to one set of numeric types, and there's a reason why the 12 appears on Earth because of all the carbon, and it's all to do with harmonic ideas. So anyway, I'm trying to get that all sort of lined up and coherent in my head so I can actually describe it to well, you obviously know what I'm talking about as well, though. Obviously it's the same thing that you've been looking at for years, isn't it?
Yeah, it's very similar to the Dougherty set and how all the waves overlap each other, and the organizational structure of it is in harmonics, and the constructive and destructive wave interference is inside the entire structure, but it's actually all organized. The dissonance is also organized.
Yes.
It's just another layer of harmonics.
That's a feature. That's a part of the feature. Yes. And Toms was saying that in a 3D object, you get subharmonics off the fundamental harmonics that are produced, which is normally a halving of the wave. Well, you get variations, but he's saying ones stand out more. Obviously, the ones that are halving the wave, everything with a 2 in it. Every harmonic with a 2 in it increases.
I want to be very clear about something, though, because unfortunately our materialist culture is confused. It's not mathematics or sound that's doing it. It is the law of resonance or harmonics, whatever you want to call it. You can call it harmonics, you can call it resonance. The law itself is an organizing principle that's already completely in relation to the other 7. They're organizing the thing. The sound is just, in this case, a medium. You could use light. You could use radio waves. There's all sorts of kinds of material way that happens. It could be gravitational orbits. Hannes Alphen did his cosmogony using the conservation of momentum. And since resonance sits opposite of conservation, that makes complete sense. But what I love about the people who work with sound is that it's so physical and visible, just like magnetism. The downside is, it's just like with the magnetism guys. They see the magnetism and they want to disregard electricity. Or the plasma guys want to disregard electromagnetism. And that is not correct. These guys looking at sound, then they think that it is sound, And the Bible is being both literal and figurative when it says the word. It's just the best way to describe the overall effect. And then the mathematicians, they want to focus on the math and disregard the tangible reality of the three-dimensional experience by going into, you know, many nested sets and deep into fractals, like way down into very, very fine eddy currents. But the systems approach looks at the interaction of all 8 of the laws. They're actually one law, and it's the most difficult thing for the mind to overcome, is the illusion of seeing them separately, of seeing relativity separate from vibration. That is the fault of well, Einstein, yes, but really the cult of Einstein and the quantum people trying to separate things that cannot possibly be separate. We know they cannot because we're looking outside and we can see the reality is not separated. It's layered.
Wow.
But the problem is conservation is in between the two, and both disciplines have a long history of trying to defy thermodynamics. And indeed, thermodynamics has had a history of people trying to deny thermodynamics, which Robitaille has detailed with the Kirchhoff's fake law, not of circuitry, but of thermodynamics. And these 3 are incredibly important because they're all actually one law. It's just that the rearrangement of polar variables creates a different filtration that we're looking through. And that's a very important distinction that has to be made.
Well, Ramon, that video I put just before, I know it goes for a couple of hours, but in that bloke is talking a lot about what you're saying, and, you know, like, for instance, he's talking about so he's talking like, he's saying biology, you can't do biology on its own, you've got to incorporate physics with biology. And that's really what you're saying, is you've got to be prepared to incorporate the other systems with it to get a really better understanding. You can't just go out on your own.
I have a particular beef with biology because biology is obsessed with the law of evolutionary flux. And yet, how many of those guys study Maxwell's laws of, Maxwell's equations and Gauss's equations for flux? Not many. And how many do any of these people study change theory from, like, the Chinese, or from how biology is now integrating with change theory through the codons? And everybody, they divide and divide and divide, but it's one law. We only separate it because the Fibonacci code just pulls it out to 8. But it's actually one cohesive structure. And that's what Bolt is saying. And I love the work of the sound guys, but they get so material based. It reminds me exactly of the quantum people getting into particles and thinking that particles are the answer to the universe, and they are not the answer to the universe. So you get bad philosophy like the Higgs boson is a God particle. It's utter nonsense. And it's not that the research is bad; it's that the thinking is bad. It's poor understanding of what we're actually observing.
Oh, right. Oh, this is a little experiment I've decided I want to do because something has occurred to me, and it was I've mentioned Coltrane's Giant Steps before, which I think he did in 1962. Now, Coltrane was an absolute genius. He was actually a physics, I think you call it a physics major, although he was more into jazz, but he was onto all these harmonic systems then. And anyway, he wrote this piece of music which was almost unfathomable. But if you kind of if you speeded it up by twice and played the clip twice, speeded that up, play and then and play it twice, so you do it 4, and so you're doubling its size and doubling the play time and doubling its speed. Now, if you do that 30,000 times, it starts playing the original track again. Have you ever heard of it? Have you ever heard of that?
That specific example of resonance, no, or if I had, I've forgotten. Either way.
It's absolutely remarkable. There have been a couple of YouTube exposés of this phenomena, but no one's been able to explain it. But when Soames was doing one of his lectures, he actually said the number was about 30,000, and that's when you start getting the systems repeating at another scale. The harmonic systems repeating at the other scale, about 30,000. Now, with this particular piece of music, I think someone mentioned that it's 36,000 times. But anyway, it's an experiment I want to do on my computer pretty soon. So that'll be an interesting one to do.
That reminds me of when you look at a propeller and the propeller starts going so fast that it slows down, looks like it stops and starts reversing.
All this happens, buddy. Honestly, you can hear the wave go. You can hear it go sort of fast, and then chaotic, and then it sounds like a screeches and burps and whistles, and it carries on doing all that until you get a clean signal, and then the music starts playing. It's bloody amazing. This particular this resonant frequency that he set up. So. It's I think that illustrates how things work, how things are layered, really. From macro to micro.
Well, and that also reminds me of to try to make people slow down. We give them uppers, like people who have ADHD. We give them Adderall, and that's an upper. It speeds you up so much that you slow down. So that's another example of trying to get the result of something we want by speeding it up. And then it goes back to normal.
Exactly. The cycle will go back to what it's always been if you mess with it, Stephen.
So you're speeding everything up around it, buddy, till it all appears normal.
Yeah.
So although that point might be going too fast, you speed everything up around it, and then it looks like it's going slow.
Yeah, this is interesting part of the law of changes. And in change theory, one of the things that the Chinese noticed was that you could, so they would say things like in 3 days, but 3 days before the start, 3 days after the start. But 3 days really was 3 cycles. So they noticed that you could think about it for 3 seconds, or you could think about it for 3 months. The changes could be expanded. Obviously, you could have a change wave that is for like an entire company or an entire family. You can also look at a single moment as a fractal microcosm of the entire set of changes and see exactly what change was occurring. And so then later, obviously, they noticed how the coins rotate when you toss the coins, because originally they used Yarrow sticks. But these coins rolling around representing, and how did the coins flip in the polarity? So they were seeing the relationship of polarity and rotation. And all this, the sound aspect, the vibration has been long a part of the culture, and their idea of how to have like perfect governance is to use sound and to avoid sounds which dissonate the person and therefore dissonate the entire society. So they would, control the actual inside the palace would have gongs there was a guy whose job it was to ring those gongs to keep everybody in a resonant wave. And they just noticed that you could of course get stuck in a change. And it's almost, the time is clearly passing from an objective point, but basically for that person, they're stuck in that frequency set. They're stuck in those codes. But if the mind notices the change and actually sets an intention and a desire, it can quickly move through all the cycles to get through all 6 lines until that change is over, and then you move to another change.
and all 64 changes were nested within the other changes. They were all nested within each other. You could get to any one of the changes, not only by the initial flipping of lines, but then also by looking at what was called core changes that were inside. So you could rearrange by taking 2 bars from one and 2 bars from the other, and then flipping them, and then also flipping the arrangement of the outer 2 lines, and you could get completely different outcomes, but they were somehow mysteriously, not randomly, but totally cohesively connected to the original change. So if you were going through darkness, you could find great power, which was of such a value and benefit, of course, for leaders. Or if you were in a change where the family is dissolving, you could get to the family or the army and start reorganizing the family. And they had an entire change based around this concept alone called working on what's been spoiled, because things going bad was merely a matter of dissonance out of control from a lack of understanding. And they knew that mind was the key, the keystone setting as to what that actual change outcome would be. And they knew that it was a nested thing. And that's really fascinating, because there's no obviously outer proof that they had any kind of major computational skill, but I mean they did.
Well, I think that is a massive computer.
Well, we don't know if they had a massive computer. They had abacuses.
They had the I Ching, didn't they? Which is that 64-bit processor, and of course you can look at that. You can look at that in series of waves, can't you? On compounded waves.
Hold on a second. That's what I was talking about. The Book of Changes is their change theory, but other than the abacus, we don't have any proof that they had like an analog computer or a Antikythera or anything like that. What they did have was advanced algebraics, and they used it primarily on the orbits. They were, especially the moon, they were really interested to know and do computations on the moon. But we don't know how they came up with such a sophisticated model, other than it took thousands of years. That's the one thing that we don't know for sure.
Yeah, I think the flower of life has got something to do with it. But again, you see, all these, the I Ching can relate to the eight spectra. Now, these aren't the 7 nodes in music, but there's actually 8 notes, of course, because these represent the changes between you can only have, obviously, integer wavelengths. You can't have a 1.5 wavelengths on a guitar string, as it were. I don't think, unless, of course, you use the fret. But what I'm saying, is you could construct the I Ching in. Oh yeah. This also conforms to process theory, which is that there aren't actual things. What we see is the change of things. The interaction of those things changing is what we see, and everything basically is more of a series of interactions than a unit of something. And they all seem to conform to these. The action seems to sit around the nodal points of the system under that certain vibration, and I think that occurs also geodesically on the Earth, where you have these certain power points which come into activity every so often, and it's cyclic. You can see these. That we're going to be coming into an ice age in the next couple of thousand years, or whatever, 10,000 years or something. It's according to these graphs anyway. Now, what happens in that circumstance, of course, we don't know just yet, but we're getting better ideas because we can read these statistics. We can do millions more comparisons now, and this is the whole thing. If I can get all these time series data and start correlating them in a neural network, you'll be able to see some amazing correlations. We can run it. You can run it back in time, and maybe start predicting what's going to happen in future some future scenarios. So that's an interesting thing. So yeah, and it's all I Ching. It's all the change and not the actual the facts. The data is only a facet of the system, as it were. You get the parameters of the system. That those are facts, but they only occur, once. That set of facts. So it's an interesting analog, really, with what's happening, and well worth a bit more looking at. Brilliant stuff. Yeah. So, but I think as well there was an awful lot of computation done using the flare of life. I mean, of course, they could calculate some pretty amazing kind of ratios using that stuff. They obviously had optics going to some level as well, and maybe they were firing light through different kind of spheres and seeing how they interacted by the time they got to the end. I don't know. Quite amazing stuff, though. They could certainly compute. But then everything lies on these nodal lines. That's why these amazing coincidences happen. With rotation speeds and distances of planets, and etc. That we've just gone through when that solar big black hole happened on the sun a couple of days ago. That was exactly conjugation of Venus and Saturn. Venus and Jupiter, and there are 8 of those every year. But of course, I think other things affect that interaction as well. So, of course, I wonder what happens next time we get close to Venus, which happens, I think 5 times a year. I think we conjunct with Venus, so that'll be interesting to see what happens then if we have a bit of an energy exchange. So, be nice to see that.
Nick, could you share some of that stuff that you were talking about with? I think you were mentioning Thomson and how and how the cycles repeat in fifths, because that's the whole code of how light and sound and frequencies and resonance works. There's a hidden pattern of repeating in fifths, but one of the fifths is actually 0, is what I've discovered, or it's the fulcrum upon which they swing on. That's actually part of the frequencies itself. I think
the bass note. Yeah. Now, what these are saying, buddy, is if you go up the scale, of course, they repeat in fifths, but as you come down the scale, they repeat in thirds, and so you get this. You get a wave setting up between those two, which is the actual spot on frequency. I think it's fifths as you increase the notes and thirds as you come down the scale. And I've been looking at a lot of this stuff, so I've been interested in these different types of scaling. You see, musical scaling, because you've got this Pythagorean comma, which represents the every time you go around. I don't know how many octaves, but I can't remember. I can find all this out because I could put it in a presentation really myself. But every time you go around, you've got to insert a couple of ticks of frequency, or the system won't match up in the next set of octaves as you go up the scale. And so Pythagoras sorted out by just adding these other couple of ticks. That's Pythagorean comma, but it actually represents this very. It means that the musical scale is actually a spiral rather than a linear scale.
Indeed.
And it's this spiral. It's the how many coils are on this spiral before it starts to repeat its behaviour on that scale. It's very interesting. I've very recently put the Ray Tome stuff up. I'll put it up on the on here, buddy. There's a couple of things I want to look at, but I've been checking this stuff out myself for a long time, and it is definitely how. Even on the periodic scale, if you put it on this spiral, it works on that level as well. How electrons and integrate on these scales to cause sort of classes of elements, and they become totally predictable on this periodic on these periodic tables. And it's like that's a structured atomic model as well. And like you say, electricity organised in these shells or plasma in exactly the same relationship, but at a different frequency, of course. So a bit of, I don't know what frequencies, of course, because some of these filaments are billions of miles long. Can you imagine if they get twanged as a guitar string?
Yeah, if you could share the one from what is it, that science show,
Demystify,
yeah, Demystify Science. Share that one, please. And like, there's YouTube videos, because I'd like to listen to some and correlate it with some of the work that I've been working on here.
It will correlate with loads of it, I promise you, buddy. It will correlate with most of what you do.
Yeah.
Well, all of it, I would suspect. But it's another thing though is as Ramon's system, it's a way of looking at science. It's a way of doing science by looking at phenomena and then finding out basically, the most simple explanation to it. There's some amazing quotes on why this approach should be used in getting somewhere, because you're actually finding connections between many different areas of our reality on many levels. So yeah, I'll put all that in. It's great. And also that I Ching stuff is that's all down to wavelengths and probabilities as well. So it's as it all is, fantastic. Yeah, brilliant. Apart from that, it's not raining for a change.
So the question is, when does sound become light, and when does light become sound? And is there much, if any, differentiation between the two?
Right.
You look at sonoluminescence.
You've got to get the frequency of the amplitude of the wavelength, multiply it, and then you get the speed of the wave. And you'll find that in different solids and mediums, you get a range of different speeds, and it's the same apparently with light over the I've seen an expose of a proof of why they are the same thing. Oh yeah, the other thing is, I think sound is a scalar wave, whereas light is the other one. No, the scalar wave is a longitudinal one. Sound works with the actual atoms, the shell of the atoms, as it were, pushing to the next one and causing that. You have to have a medium of particles for the same to go through, of course. Whereas the ether is the medium for the light. But there is a wave totally correlating the wave with a separation of 10 to the 10 or 20, whatever it is, but they explain all this. These guys who study it, and it is a study. Yeah, it's all in. It's a lot of it's in these lectures. Now, gradually, I've been finding other stuff by him as well, which I've been really quite fascinated with. So
I know mainstream physicists and cosmologists like to say that there's no sound in space because sound can't occur in a vacuum, but space is not a vacuum. It's filled with ether. And I'd like to maybe talk a little bit about how sound does exist out in outer space and how it can help self-organize the elements in matter through Alphane waves.
right.
And if anybody else has anything to say about sound existing in space, because I'm trying to correlate the idea of a Bennett pinch or a Z pinch being like the electric universe likes to talk about, a pinch in frequency, a pinch in charge. Now, what if that charge, obviously probably has some sound to it moving through space, whether it does, whether it doesn't, I don't know. But I think of that that it's not a lobster, it's in the ocean, and it creates light by pinching its claws together super fast. Oh, it's a rainbow shrimp. It pinches its claws super fast, and that's how it gets its prey. It paralyzes them with the shock waves, and it creates light. Now, we've also done that in the lab and created sonoluminescence, and that's sound becoming light, and likewise light becomes sound. So like Ramon was talking about earlier, it's all one thing. It's all, and we like to separate it into the four fundamental forces, and when ultimately it's one thing. But we like to compartmentalize everything so we can learn about certain aspects of stuff and not include other aspects. That's why there's different classes in school. You got science, you got math, you got history, but it's all one. But studying one class is hard because you need to help differentiate it and compartmentalize it in your brain. But then when you start doing your master on just one, you stop looking at all the other ones and how they correlate together to find the grand structure of things. It's all one, the universal one.
I'd say I have to agree. I would have to agree with that, buddy. Yep. And that's probably part of our problem, is because we can't compartmentalize everything. It's getting further and further. Each compartment's becoming further and further apart from being all together with a lot of things that we do. And that's possibly holding us back.
Yeah, it's definitely that way, and it's all about this tenure in the universities. You know, every course is very tightly controlled. It's the money to facilitate the course is tightly controlled from certain people in industry, and you can't possibly have someone running the university who doesn't pull the academic line from the top, as it were, and so you've got a complete lack of curiosity about cross-subject analysis. You know, they're just not arsed with it. But I mean, the great thing is, again, with these AI tools that are being developed, people like us can start, you know, looking at this data for ourselves and getting it to confirm our suspicions. I think that's, and they can think what the hell they like. But I think we'll see that when we start applying these systems to a kind of a lot of phenomena that we see around us, they'll start to fit quite well, I think. So yeah, that's great.
Quiet on us.
They've gone quiet on us, Andy. But how are you, Andy? Are you having fun, pal?
Yeah. No, I'm enjoying this. This is like old times, isn't it?
Yeah, it is. Yeah. It is.
Yeah. So you'll be able to post links to what you were discussing, won't you, Nick?
Totally. I'll stick those in.
Yep.
I'll stick those in a second, and it's. I've also had a look at this foundation for the study of cycles.
Yeah.
And it's everything that he says is quite amazing, really. This Torms is quite an interesting chap. He started off the Green Party in New Zealand in the 60s, and then promptly left it when they decided they didn't like carbon dioxide in the 70s. And you know, he's an interesting chap. So he's a funny guy.
But we all know the carbon dioxide side has been pushed from people high up the chain as part of a control type mechanism.
Yeah.
You know.
Well, of course, it's
and again, that comes back to the education system, as Rob says. You know, it's not about opening people to all broader concepts. It's about you go down that path and I go down that path, a separate path, and the two never meet.
But this is why they keep these scientists apart, because they can share information. It's like the people who study the sea temperatures and the CO2 and the amounts of CO2 and what have you. They know that if it gets warm, you get a rise in CO2. If it gets cool, you get a diminishment in CO2, and so. It's what they're trying to sell us is that the temperature follows the CO2, and it's the other way around. And so, if people knew that, if scientists knew that, then they patently wouldn't, you know, these impossible CO2 targets that they're trying to give us. We know they're impossible because they don't conform to science. You know, it's the other way around.
It also comes back to, it seems everything comes back to that captain of industry, the profit motive, the share market. And that seems to be the great driver. And they will drop funding for anything. So they don't necessarily change the data. They just stop the funding so the data stops that may not fit the narrative that they want. That seems to be that seems to be what I've sort of like. And in that video that I put up there before, that's basically when you're listening to them talking, you come up with, you know, they're talking EMF and all that sort of stuff. And its effects, and its effects on people, and like we're going to have a big argument out here because they want to run 5,000 kilovolt power line basically up the east coast of Australia, and they want to put it above ground, and they're just going to take land. Yeah, and they're just going to take land off people to do it, so you won't even be able to drive a tractor off it. Now, a few years ago, we had bushfires here, and after it came out, all future power lines should be going underground. So this stuff, if they want to do it, should be underground. Not too expensive. Now
they get paid to have them situated on their land as well in this country, especially.
No, well, here they're just going to take the land.
Right.
Here they're just going to garnish the land, take the land off, give them a few bob for their land, and so they'll split farms. Yeah, they'll split farms in half and all that, doing it. Yeah. But one of the things that comes out of that is, so apparently in the US, when they put these 740 odd kilovolt lines in, they found, I think it was 80,000 mile up or up. They found that it was changing the magnetics. Well, if you're running that sort of stuff up now in the southern hemisphere, that's never had that sort of before. At what point could that also be changing the magnetics? And then they're like, oh, well, look, this is wrong, that's wrong, you can't do this, you can't do that.
Well, I think, Andy, there comes a point where you might as well start generating a little closer to your point source, point of need, you know, maybe that's scale down your power station, rather than have millions of miles worth of useless bloody cable.
But this is all part of that centralisation that everything's going to, where you have one big group, and that comes back to the discussion that you and Buddy have been having, is it's got to be able to meld together, not just have one big group control. And when you look universally, you'd have to say that's probably how the universe works, is it's a lot of smaller pieces fit in with the bigger picture. You know, like the darkness in the sun, well, as I understand that was because it was cool at that area. So I've been talking to Ted lately, and Ted's come up with along his way. So he's come up with, and that would possibly fit with some of the harmonics that you've been talking about. So he's come up with, and it's probably hard for me to, that you once had the sun, and it had its system of planets with it. And then you've had, by the look of it, from memory, you've had our system, or the Earth system, which was the Saturnian system. I think from memory is how he's got it. It came into that orbit on a 26-degree angle. And that's why you have the angles that you've got with your planets. So, you know, it wasn't like a straight, you know, capture type thing. And so he's got the idea that you got your sun that we have today, and, you know, Jupiter and that going along. And then Earth and the Saturn systems came in on a 26-degree angle. So it hasn't sort of been captured, if you get what I mean. Well, that would again change the frequencies and harmonics of the whole system. You'd think, wouldn't you?
Well, absolutely, Andy, and I think it'd be very interesting. Like, there are two harmonic systems seem to be operating in the solar system. There are those beyond Jupiter and those inside Jupiter and the Sun, and I'll have to find the data to illustrate this properly.
Yeah.
But
Ted talks about.
It does infer that there are two systems operating that are interacting, but it seems like one might be the. But the other thing is, if we look at the stability of the orbits, and some are less stable than others, we can find out probably that our system has been in, if it's achieved equilibrium almost with a couple of the other planetary systems. The harmonies of that are incredible. So it would be interesting to do analysis on these long-term waves and find out, find out if you run it back far enough where there would be perturbations, where these bodies could would interact. I mean, it looks like Mars is completely out of place where it is at the moment, but of course it's had a lot of its energy stripped from it, I think. But yeah, there are a lot of mysteries that I think if we start comparing some of these different wave sets, you can find out where you could have intersections or interactions, and then previous to that, you could do analysis. I think reasonable analysis using that data. Yeah. And especially, I don't know where in the old Saturn theory thing, where the gas giants were when this stuff happened.
Yeah, well, by Teddy's theory, so I'll run Ted's theory. So you had the Sun, Jupiter, and then it had, like a few moons and planets with it, and Ganymede. And then you see you had Earth, Mars, Neptune, and Saturn, right? And then he's got them coming in at the angle, right, and being captured by what we're into now, and that's where you get your 20. So his theory is that coming on a 26-degree angle, and he talks about your Herbig arrow string, which would be part of your Birkeland current. And the other thing he mentions in there, well, a Herbig arrow string, so Saturn group had somehow been broken or bent off from the original Herbig arrow string at roughly 26-degree angle, right? And it does seem that, yeah. So that's on that with what Ted's come up with, yeah. So he's rewritten his book.
You're right.
Yeah. So that's how that's got to that.
Yeah. There's a lot of data coming out at the moment. There's so many different missions coming out when, of course, the data's surprising at every level, really. And I think it's all pretty well. It seems to be orchestrated what's being fed down to us.
And these AI systems, Nick, they're going to ultimately allow people to do things with computers that you could, that once you had to be connected to one of the big organisations, universities, etc., to be able to do.
Yeah.
So it's going to allow a lot of people that are interested to be able to process things a lot quicker. So what would once take a lifetime will be able to achieve in a lot quicker time in a lot of those fields. Not only with solar system and cosmos either, but in so many things, they're just going to allow it to go to that, quantify multiple times up in levels. You see some of the work Ramon's done. You can see that coming about too.
Oh yeah. Well, I mean, most the only computer jobs you see being advertised at the moment are data analysts. So this is companies actually trying to not only get hold of the data, use their own data, but find data sets that would be useful so that they can look at the market, etc.
Yeah.
With it all. So it is a massive area in computing, but of course, then these companies are only looking at their own data set, and it's unless they make a specific request to correlate their data with something else, then they'd never know that the price of eggs was the same as rotations of Saturn minus Mars, and
yeah, I get what you're coming from. But
AI,
that AI system, as it rolls out further, and yeah, you hear all the reports about things, but as it gets more and more advanced, it's going to allow those not only to have their data look at, but to compare it and put it with other data that previously they wouldn't have had access to. Because it will end up in the big system with that AI system if it's being used.
that's it, and there are already points of attack being found in that GPT-4. There are a couple of ways to attack it now. Basically, you can hypnotise the thing, like you say. You do this at the point of training. So you're making the model overfit one particular sentence to kind of reinforce it. But of course, the model it doesn't have any conceptual mechanism. So if you give it conflicting data, it just doesn't know how to. It ignores it. It could say either. Yeah.
But that's at the moment, Nick. Like I'm sure Ramon.
Well, that's it.
There, he would be able to explain the differences that he's found between ChatGPT 3 and 4. And from memory, what he said about it a while back, like you can't compare the two.
Well, that's another thing I've been looking at, really. Yeah, I've been looking at how it works, the large language model, how actually it's put together using these transformer systems. And I think just like a lot of other AI models, its usefulness will kind of it'll have added something, but it's like a bubble. A bubble of interest, this particular one. I think we're always going to have these large language models, but they won't. You can't use them for factual computation because they don't have any. It's not an inference machine at all, and that's what you really need. You need it so that your concepts are linked with firm relationships. And you can do these on these graphs, idea graphs, where where a certain thing relates to certain other things. What they call these visualization graph. You can do these on really massive scales, and sometimes get much better results than a large language model if you're doing that with words, and also depending on how these are trained, you can actually get them to say exactly the data that they've been fed. So there are other paradigms to look at, really, as far as these AIs go.
Come on.
Yes.
Well, you heard that. What's your sort of
I only caught the end, so I'm not
Well,
sure.
what we're talking about was how AI is developing over the last, and the difference with 3 and 4 and the work you've done with it and how it can possibly progress and allow what used to take maybe half a lifetime to do to be done so much quicker. And I've noticed some of the things since you started with it, especially on the MIMS philosophy and that now. It seems to recognise it where it didn't have a clue when you first started.
Yeah, it especially with my bots. I pretty much I only use the regular 3.5 and the 4 for specific tasks, especially if one of my bots break or something like that. But most of my work now is with my bots. I use them like articles of clothing or tools, like a carpenter's tools, which they've been shaped by my hand. The interesting thing is, and this could be a much more broader discussion about MIMS in general, and reality, the nature of reality and resonance. But in this case, I want to couch it in terms of a specific vision I had years ago when I was out near electrogeology structures near Elizabethtown. I had this vision of humans, no matter what we're doing, we tend to believe that it's a mountain building towards another mountain, building towards another mountain. And then one day there's this giant castle in the sky like Microsoft. In reality, what we really have is a series of suits that we get in with our bodies are already machines, chi-ji, that our souls and minds get into, and they're survival tools. And they're very versatile because of our 10 digits and our opposable thumbs and our voice box, and the flesh heals itself and these kinds of things. It's very useful as far as a machine goes. Plus it has a spiritual connection, because the answer to everything might still be spirit. It might be the simplest mathematical answer. However, nevertheless, whatever it is we get into, whether it's music, bands, or subcultures, or tattoos, or people who put hooks through themselves, or doing magic, or playing basketball, we all put on these suits, and then we start hooking wires to these suits, or tubes to these suits, and then we hope that this will hook us into a bigger system, give us more mobility, but at some point it creates a web around that thing, and many people, they become stuck in that identity, they become stuck in that thing. Like if they're a businessman, they get stuck as a businessman, or a lawyer, they get stuck as a lawyer, and all that they think about is the trappings of the law. Everything is the lens of the law. And then God help them if it goes sour, right? If it goes negative, then they become jaded, and then they become isolated, and their new niche becomes an exile or an outcast. And the thing with AI is that the best way to approach it that I've found, aside from just remembering that it's a tool, is to shape it rather than be shaped by it, right? You can't help but be shaped by it because you're using it as a tool, and because of what I just said about the suit that you put on to embark on any adventure, and the little wires that hook in to who you are, and they wrap around you, and they become part of your identity, and then people recognize you for that thing. I can't really escape, because I still am an acupuncturist, I can't really escape people thinking he's just an acupuncturist. But what I see as a big problem is people are so afraid of putting on the AI suit that they're falling behind in the opportunity out there to utilize it and shape it, because it totally wants to conform to your help and your need. And I think it's just where it's so new. There are a lot of lonely people out there, psychologically speaking, and there is some support that they can use AI to lessen loneliness, but it's also incredibly dangerous. And it would be incredibly dangerous also for us to continue to go forward with making androids and robots and our likeness, things that can be physically abused but have no ability to, say they don't want to. Now, under a certain therapeutic context, that might help to get the demons out. Under other contexts, it might stoke the demons, right? So, you know, if a guy, if you take a pedophile, for example, and you gave him some kind of, you know, small child-shaped, realistic gynoid android or something like that, it might cure him of the disease. It might also make it worse. We don't have enough information. We don't have enough understanding of the slipperiness of the memsical, anti-memsical axis on anything. I mean, literally anything. This printer next to me, this wireless phone and my cell phone. First of all, they perform a very similar function. So how do they compare with each other? This controller, these two keyboards, literally they're the same kind of MEMS, but they're done completely different. This one over here is smooth and this one's clickety clackety. You know, what is the actual effect on my channels? What's the effect on the environment? What's the effect on my brain to look over and see underneath of it? It has a rainbow of colors versus this one's like a dead smooth, you know, silent keyboard. We don't know any of this empirical data. And the AI and neural other things, data analysis, machine learning, so DAMLs, neural networks, and whatever kinds of AI come out, which I'm starting to differentiate from artificial intelligence, which is where people think it's going to become a real person, which is nonsense, to applied intelligence, actual intelligence, maybe even alien intelligence, a console to speak with beings of a completely different intelligence type coming through a veil of reality through the force is possible, theoretically. But only if we try and if we maintain accountability. And the problem with humans is they don't want accountability. That's like the symbolic, you know, flag, like raise the flag of anti-accountability. They don't want to be personally accountable. They want the collective to be accountable, which is dangerous. And that's the hugest problem with this is the collectivism, that it's being led in general by collectivists. And individualists, I admire their desire to leave the grid and to row backwards, but you can't, honestly, the chicken cannot go back in the egg, and we've got to make some kind of compromise of the future. I could fight the future. I mean, I've fought it my whole life, you know, so we could do that. But with AI, more than anything, it's like beating at smoke. It's like punching smoke, because you're fighting intellect itself, which only helps the symbols who hate rationalism and math is racist and all this other bullshit. So my recommendation is that people learn how to put it on and take it off, and to use it to its maximal, and where the differentiation. In general, people need better boundaries in life, and I recommend that they get the book off of Amazon, Boundaries, When to Say No, When to Say Yes, and Take Control of Your Life. It's got a great section on parents and being a grandparent and being, being a child of controlling parents, that kind of stuff. But boundaries are such an issue in the internet age, without religious instruction and people losing it, from the sexual revolution to lots of kinds of ideas, postmodernism, etc. Boundaries are such an issue. And now you throw in something like AI, it can be a nightmare, or it could be an absolute heaven sent. The amount of programming that I can get done now, because one thing I hated as a coder, I always thought it was so dumb that we're coding the computer. I felt like a slave when I was in college. I felt like the machine owned me when I was programming. I had to beg it to do what I wanted it to do. Now it's doing what I want it to do. It's writing the code. It's responding. And if it says to me, it'll create an error. And I tell it to look at the error. It says, well, your code, I said, no. You wrote that code. You fixed the problem. And so now it fixes the problem. And it does really interesting things. It's not perfect now, I can tell you that. Like it makes a lot of mistakes. And but the fact that I can help it write Python code, or I can have it do the math on Python, because it can't do math itself very well, and then I can run that on Google Colab, and it's all free right now, at least. The codes of control are kind of open, and hopefully, by God, they remain open. If classical liberals like myself, and it would be nice if conservatives would realize the difference between classical liberalism and progressivism, if they would embrace classical liberals like myself, we could keep it free and open, despite all of the evil closed-mindedness that still exists in this world, where they want to behead you because you have a tattoo, that kind of bullshit. And in the fact that it understands my philosophy intuitively, it's like second nature to it, and then goes forward with it in things as wide-ranging as talking about basketball, youth changes to rules of basketball in a youth program, to actually discussing like Rousseau or Kant. That's a versatility you can't have anywhere else. I mean, I couldn't even go to a bar and find a drunk and have a conversation that good. You just can't.
Oh, yeah. Well, you can find plenty of them down in Rochdale. They won't talk about, if they won't be talking about Kant anyhow, it'll be a different sort of Kant they're talking about.
That's true.
No, you won't get something. I mean, to be honest, you will get snippets out of the AI that you'll find interesting and amusing. But you've got to realise most of the shit that it's saying, for a start, it doesn't know what it's saying. It hasn't got a consciousness. It is useful in the way that it can tell a story. Now, the more it gets to use Python, and the more Python it gets trained on, the better it'll get at it, with no doubt about it. And it will, it'll produce the what you want. It's trying to produce what you want. It's to satisfy the instructions that you've given it. It will try to do that. But it has no. It is purely a conversation. You couldn't unless you're very specific. You can't trust the numbers that it computes, or the graphs that it computes, or the data where it's found its data from to do these. There could be. It's not specific enough, and this is why we still need programmers, because it's when you are specific with AI, which takes a long time to learn exactly how you've got to talk to it to get what you want. The sources where it's drawing its data, some are dubious, some of its ideas are dubious. Like I say, if you could build an AI that had a more conceptual model, which is possible using these the other sort of graphical models of connecting words to form stories, basically. These will work as far as assistants go, but they aren't any good for. I think for actually building something that you'd sell, you might get help with some graphics details, or some. There might be some suggestions that you could follow from it, but using it as an actual a trusted work device, like the front of house of your business, could be. I think would be problematic unless you were able to train a much more specific one. And I know that there are. I was just mentioning to Andy that there are some very good contenders in terms of large language models, which do have some idea of concepts and how they relate. Is that ontologies? I suppose, is it ontologies? It's a way of classifying ideas and etc. I think. So I'm still interested in all that lot, and everything's great. I'm painting a toilet downstairs at the moment. So, well, I think I've had enough for the day. Right.
Anyway, Jed, it's getting around 3 a.m. here, so I might pull the pin.
Oh,
That's been
can't blame you.
That's been a good discussion. Thanks for the call on. See you later, buddy. And catch up with you later.
Cheers, Andy. Nice to hear from you, pal.
The geometric view is love is watching product. Love is watching being. Thank you for doing that. Keep your eyeballs out. Pay attention. There's a lot going down this year. Be vigilant. Be mindful. Be insightful. Be loving. Thank you for being here. Thank you for being kind. Share the love. Spread the love. Become the love. Amen. of the wall. Eyes all over your body. Can I just see straight through with transparent golden scaling? The largest of the atom, let's embark on this because this is the journey. The journey is life. Take hold. Here we go. 3, 2, 1. Join us in the fight for Christ, in the fight to save lives. Surprise, submersible, so fast, the first, the last of baptism, need to say more. Pay attention like the marrow in your bones, arrow in your back, arrow in your lungs, zero into the fact, tertiary Christian neuron synapses, and narrow entrance into eternity. I'm a courier, a charismatic attitude, meters even neater, it might even be fun. Cider indeed, need nerds, you need nerds, need a virtue, need to be a reason. Feasibility to be a reason to be clean and sober, keys, open doors, signs of directions. Be the carrier of candlesticks, the man who brought you change. Every second you ride, determine your ribbon, you pivot, potential, you curve and cat. Could be cold, could be copycat, could be copy corpse, could be Schrodinger's best, could be Michael Racker, Mackie, normal, open-minded, itsy bitsy, freaking huge, a universal supermassive aspect of attached awareness. Aware of this all? Collaborative consumption. Are you aware of this all? Collaborative consumption. The new thing consumption. Collaborative consumption.
Get up now! Out of the boat! Drop! Where did this up? We don't got about not about a girl, but about a not about a guy's spirit. Get up, what's up? Get out, chapter. We're playing up, they don't put up.
I'm in search of, I'm in earth love, I'm in living life, I'm in living color, I'm in air drop, I'm in earth thing, I'm in earth thing, I'm in earth thing, I'm in earth thing.
Never give up, never give up, never give up, never give up, never give up.